Let's read this one very carefully. If G, capital G, not that it matters that it's capital G, is an antiderivative for little f. Okay, we're dealing with two separate variables here, so let's not even talk capital and lowercase. If G is an antiderivative for f, oh, okay. G is an antiderivative of f. All right, keep this in mind. We're just going to use G here instead. G of 3 equal to 12. That is an incomplete sentence. So let's fix that incomplete sentence this way. There we go. Comma, lowercase w. Write an expression for G of 10. Here goes. I need G of 10 to pop up in the process of this. And again, we're dealing with the antiderivative of something. So I'm going to need a G of 10. Well, let's do it. I would like to just write G of 10. Well, I can't just write it. What I will do instead is say, well, you know what? I know that G is an antiderivative of f. That looks like this to me. What numbers do I put here? Okay, well, what values would I plug in? Well, I need there to be a 3 and I need there to be a 10. So let's just do that. 3 and 10. Okay? And this is equal to, well, the antiderivative of f, which is G, evaluated from 3 to 10. And this is a different way of writing the same thing that's happening right here. So we have G of 10 minus G of 3. Okay, write an expression for G of 10. Well, let's just keep going. So here's what we know. We know that this equals middle step, which equals this. So the integral from 3 to 10 of f of x dx equals, skip it, G of 10 minus G of 3. Oh, that's 12. Okay, good to know. So what's G of 10? G of 10, apparently I'm having a hard time writing a 10. G of 10 is equal to, and I would move this 12 over to the other side, and I would have 3 to 10 f of x dx minus 12. Now, they didn't say find out what G of 10 is, like give me a number. They said write an expression. Done. We have an expression for G of